Good morning, everyone. Hopefully you guys had a good weekend. Looks like more and more of you are trickling into chat, so if you would give me a green check mark when you're in there and let me know that everything's kind of working okay on your end, and then we'll get started. Where are we at? We're lesson 6. I put lesson 6, lesson 4. That's confusing. Unit 6, lesson 4. A bit of a typo to start the day. It's okay, Monday morning. We have lesson 5, which will be tomorrow, and then we have a review day on Wednesday, and that's it for this unit. So we're pretty much done. Unit 7 is the next one that's coming up, and Unit 7 is really short, and it is a lot of algebra, manipulating equations, like line equations like we've been dealing with. So it's not difficult, but it's just algebra. So if you love moving variables around and solving for different things, you should be okay. But if you're kind of like, algebra, then you may just, struggle with it a bit. I would really, really like it if everyone was all caught up before the break. Yeah, sorry, I should probably have started with that. You guys, the schedule that we had on the website, Mrs. Wood gave it to me like 2 weeks ago, and I didn't look at it until this morning. And then I came in this morning and I looked at the schedule for the week, and I noticed that all of my blocks were backwards. So I have class when she scheduled me in here, so I was double booked all week sort of thing, because I have my class that I teach at KSS. So basically, she changed the schedule on the homepage, and math will be, if you're looking at the old schedule, it'll kind of be opposite. So we'll have math late today, and we'll have math late again on Wednesday, but tomorrow's class will be first thing in the morning for math. So yeah, it's opposite of what it should be. So hopefully that kind of clears things up. I know that the new schedule should be up on the home page now, and we'll have English. Yeah, so it's just kind of backwards. Why don't you have any English? I don't know. I think tomorrow Mrs. Ward is at a conference. You guys, looks like, I'm just looking at the schedule here in front of me. It looks like this is the week of the 7th. So you guys have English on tomorrow, and you'll have English on Thursday. So 2 English blocks this week. It's just in the opposite order of what they were listed on the schedule. So if you have an old copy of the schedule, it's the opposite. If you looked at the new schedule on the homepage, everything should be correct on the new schedule. So it won't look any different. And then we just changed the numbers. So tomorrow says only math. Yeah, I'm just looking at what I have in front of me here, and I'm thinking English and math, but they're in the wrong order. So you'll have English second tomorrow, and then you'll have math first tomorrow. So we'll start the day with math tomorrow morning after you're done with Mrs. Wood in homeroom. And then we'll have English after that. It's looking like Wednesday we'll just have math, and then Thursday you'll have both again. So hopefully that kind of clears things up. I know it's kind of a bit backwards, but look at the new schedule and everything should be pretty straightforward, hopefully. Okay, so where was I? We should be done Unit 6 this week. So we have today's lesson, tomorrow's lesson, then a review on Wednesday. And then I was hoping you guys could have the kind of review submitted on Thursday, the learning guide, and then write the test on Friday, or any day after Thursday, but between Friday and Sunday. Because we're going to start Unit 7 on Unit 7 on Thursday. And then next Monday, you guys have the English midterm. You guys are writing an essay, I think, in the gym at Central. And then we only have 3 blocks next week. So there's only 3 lessons for Unit 7. So we're going to do Thursday, we're going to do Tuesday, Wednesday, and then review on Thursday. And then you guys will have the whole break to write that test. As well, we're going to try to pre-record Unit 8 so you guys can watch it over the break if you like. If not, it'll be pre-recorded, and then we'll do kind of like a flipped sort of idea where you guys will look at the videos and then come to class and ask questions after the break. So lots of stuff happening. Does anybody have any questions from the learning guide? There's 2 weeks, Alex. So we have this week ends on the 11th, and then next week is the last week, so the 14th through the 18th, and then the winter break starts for 2 weeks. Units left. We need to finish Unit 6. We need to do Unit 7 before the break, and then Unit 8's after the break, which gives us basically, it's about 3 weeks after the break before the end of the term, and then the provincial exams are in the last week of January. So I know we're looking like a long ways away, but it's kind of good to look into the future. I'm seeing page 5, number 5. Slope-intercept, page 4. Sure, we can do that. Anything else? Expand that out a little bit. Anything else from the learning guide? Don't see a ton of people in chat or asking questions. So let's go with page 4. Are you looking at number 4 there, Alex, or something else? Slope-intercept, page 4 of the learning guide. Like converting to slope-intercept form, or circle the equations written in slope-intercept form, like 3 or 4. Number 4, perfect. So number 4, I did 2 of them already. And the idea here is that you're rearranging these equations to get them to be y equals something. So when you're looking at them, they're all kind of jumbled up in the question, and then you want to get y by itself. So in terms of just pure algebra, not even thinking about, x's and y's and b's and anything like that, you just need to have an equation that says y equals something, and then we can figure out what that something is. So I think I've done most of these, but let's see which one I haven't done. Have I done D yet? I don't think I have. Let's see if I can do D right now. Get this stuff out of the way. All right, so this is letter D, which starts 4x plus 3y equals 12. Now the whole idea here is to get y by itself. So I'm going to move everything that's on the same side as y to the other side. So I'm going to subtract 4x from both sides. I'm going to end up with 3y is, because I know where I'm trying to end up, I'm going to write this as I'm going to write it as negative 4x minus 12, or plus 12, I should say. So I'm just putting the 4x in front of the 12. And then I want to divide everything by 3. Because I'm multiplying y by 3, I'm going to divide everything by 3. So the 3 goes away. So I end up with 3 divided by 3 is 1, so I get 1 times y is just y. I get negative 4 over 3x, and then 12 divided by 3 is plus 4. So now I have this in the form, sort of the general form, slope-intercept form, as y is mx plus b. My b is plus 4, my slope is negative 4 over 3. I guess the tricky step is this guy right here, where I divide everything individually by 3. Traditionally, you probably, when we're dividing both sides by 3, you would be thinking, okay, I just divide everything by 3 like that. But if you break it up and divide it by 3 under each of the terms, because we know we're going to end up with 2 terms on the right, makes your life a little bit easier in the long run. So I guess that's kind of the tricky bit there. Hopefully that helped you out, Alex. The next question was number 5, page 5. Taylor asked this. Yep. Find the slope of lines that are parallel and perpendicular to a line with the equation y is 4x plus 2. Last day, we looked at parallel and perpendicular lines, and we came up with sort of 2 definitions. A line that's parallel to another line will have the exact same slope. So if our slope is 4, a parallel line will also have a slope that's 4. I guess the trickier bit came with the perpendicular lines. We said perpendicular lines have negative reciprocal slopes. So let's look at what that is. Right here we have y is mx plus b. I know my slope is 4, I know my y-intercept is 2. So if I want to find a line that's parallel, if my slope is 4, a parallel line will have a slope of 4. So that's pretty good. And then a perpendicular line. If I have a slope of 4, or 4 over 1, if I have a perpendicular line to that, I'm going to flip it, get 1 over 4, and I need to add a negative sign. So negative 1 over 4. So that was page 5. Number 5, just getting back to the definition of parallel and perpendicular lines. So, if there's no other questions, I'm going to jump into the lesson for today. This unit is, I mean, it's kind of visual. You're doing graphing and things like that, and it's not terribly hard. There's a few little things to remember here and there. The great thing is when you're doing questions like this on a test, if the way that it's asking doesn't necessarily work, like if it's like plot the line or which line is representing this graph or something like that, we're going to learn today and tomorrow 2 different ways to like plot lines on graphs. So if the way that you are supposed to use isn't working, you can always just switch to one of the other forms if it makes more sense to you. So let's jump into the lesson. If you guys have any other questions, we can always go back and look at them. So we're on lesson 4. It says lesson 6, lesson 4. Probably should say unit 6, lesson 4. Sorry about that. All right, so far we've had the general, the slope-intercept form of a line. Y is mx plus b. And that is really great, except when we have our first example here. So construct your understanding, determine the equation for this line. We have a graph, and we have a line, and we're supposed to figure out what the equation of the line is. So if we look at it, we've been given 2 points on it. We have a point here, and this is looking like -1 and -3. And then we have another point here, which is looking like 2 and -1. So we have 2 points. We can find the slope between these 2 points. So rise over run. If I go up, rising here, I'm going up 2 units, and then I'm going over 1, 2, 3 units. So my rise is 2, and my run is 3. Rise over run. Can anyone see the problem we're going to run into when trying to figure out the other important information for this line? Remember, the 2 things we need are the slope and the y-intercept. What is the y-intercept going to be for this red line? Can we just look at the graph and figure out what it is? It's not on a coordinate. So it's not going through kind of like a perfect set of grid points. So you could estimate it as -1, but that's not going to be exact. So because it's between -2 and -3 in here, it's really hard to tell what it is. So we can't just write b is 2 or b is -3 or just a whole number. It's not a whole number. It's going between -2 and -3. So the regular way that we figure out the equation of the line using the slope-intercept form won't work for scenarios like this. So it's going to happen, and we need to figure out a different way to deal with it. So let's maybe write down a few little notes here. Since there's no y-intercept at an integer, we don't have y-intercept at an integer, we can't use the slope-intercept y is mx plus b, because we can't find b. So So that's a bit of a problem. So what we have to do is we have to use algebra to actually calculate what b is. It's not going to be a whole number. It's not -2, it's not -3. It's somewhere between those two things. So this is what we're going to do. We're going to take the fact that we know a point. We actually know 2 points, 2, -1, and -1, -3. And we know the slope because we counted out our squares from our 2 points. We found the slope. So we know a little bit of information about this line, and we're going to see if we can use that information to kind of calculate what that y-intercept is going to be. So we're going to use the y equals mx plus b. I've completely run out of room here. Where am I going to fit this in? So we're going to use y is mx plus b. And we're going to use the fact that we're going through a point. I'm just going to randomly pick 2, -1. And we know our slope is 2/3. So we know a lot of information. We know it's a line, so we can use the slope-intercept form of a line, but we don't know what that b is. We know the slope, which is good, so we can figure out what m is. And then we know 1 point, so we have an x and a y value. So we're going to use all that information and kind of plug it in. Now, I know you guys probably don't have any room either. I'm going to just do this all right over here on this right margin, and I apologize for not leaving enough room for it. So we have y is mx plus b. We know m is 2/3. We've already written that down. And we have a point. I've chosen 2, -1. And remember, this is an x value and a y value. So I'm going to plug all of this information into this line. So y is -1. So I have -1 equals, the slope is 2/3. And then x is going to be, from our point here, x is just going to be 2. So I've just substituted things I know into the equation. I know it's a line, so I can use the equation of a line. I know a point, an x and a y, and I know a slope, but I don't know b, so we want to solve for b. If I can figure out what b is, then I can go back and I can figure out the equation of my line. So I'm just going to do some BEDMAS algebra and see what I end up with. I have -1 here. I have 2 times 2 is 4/3 plus b. I'm trying to get b by itself. So I'm going to subtract 4/3 from both sides of my equal sign. So I have -1 minus 4/3 is equal to b. Yeah, we're just going to use algebra to solve for b. Okay, adding and subtracting fractions. I have -1. I'm going to change it to -3/3 minus 4/3 is equal to b. And then -3 minus 4 is -7/3 is equal to b. So that has calculated what b is. And is it what we expected? Well, 7 divided by 3 is going to be 2 point something, because 3 goes into 7 twice. So that's between 2 and 3. So we're on the right track, because that's kind of what we expected. So the question was, write an equation of the line. Now I know the slope, because I used my points at the very beginning to go rise over run. I have my slope. I have a y-intercept. I've solved for it using algebra. And I can put those two things into my general equation of a line. I'm going to write it under the chart here. Y is mx plus b. In this case, I have y is equal to m, which was 2 over 3, x, and then b was minus 7 over 3. So this is the equation of that line. That's what the question originally asked for. The relationship between the slope and the y-intercept, Abby, I might be wrong. Does the y-intercept have anything to do with the fact that the slope is 2 over 3? No, I think it was just a coincidence that those things both popped in there, the divided by 3. The y-intercept is in a third. So yeah, just sheer coincidence that it was 2 over 3, or 7 over 3 and 2 over 3. Yeah. Just dumb luck. Okay. So all of the examples we're going to do today all have a y-intercept that isn't a whole number. So up until this point, the first 3 lessons we did, every time we had a y-intercept, it went through an integer value, -2, 5, whatever. It always crossed that vertical axis at an exact coordinate. So moving on into the unit, all of today's stuff will not have that perfect y-intercept. So we need to come up with another way of representing lines that doesn't have this perfect y-intercept, because it's going to happen a lot where it doesn't go through an exact integer value for that y-intercept. So what we're going to do is this. We're going to come up with sort of a general form, and this is called slope point form for the equation of a linear function. So we're going to just develop a formula. I hesitate to do this sometimes because students are like, well, you guys spend so much time trying to figure out what I'm doing. Think of it this way. I'm going to come up with the formula. If you can follow along with the algebra, that's fine. It's only like one step, so it's not terribly difficult. But if you don't understand any of what I'm about to do is like a general case, then don't sweat it. We're going to write a formula at the bottom. It's on your formula sheet. It's all good. But sometimes it's nice to know where these things come from when you're sitting down to write a test or something like that. It makes sense. So you can see everything in this example is all really general. It says the slope is m, the point is p, it's x1, y1. We have another point q, which is x, y again. And there's no numbers in there at all. So what we're going to do is say the slope, m, is rise over run. So on your formula sheet, you also have slope is y2 minus y1 over x2 minus x1. So that is the slope formula. Now, there's no mention in that slope formula of y-intercepts. There's no letter b, which is okay, because we're going to have some times where b is not an integer. So we're going to use that sort of idea. So what I'm going to do is I'm going to just try to not necessarily isolate anything, but I don't like dealing with fractions. So I don't like having that x1y or x2 minus x1 on the bottom. So I'm going to bring it to the top on the other side. So mathematically what we're doing is, you can think of it as cross multiplying, if you're familiar with that idea, or you can think of it this way. If I have an x minus 2, or x2 minus x1 on the bottom, I want to get rid of it. I'm going to multiply both sides by x2 minus x1. So over here, this is going to cancel and this is going to cancel. So what I'm going to end up with is x2 minus x1, so these are just x points, times m is equal to y2 minus y1. So I've just gotten rid of the fraction essentially. Now the last thing I'm going to do is I'm just going to change the order of my stuff over here. So I'm going to write this as m times x2 minus x1 is equal to y2 minus y1. So that's all I've done. Just kind of rearrange that slope formula. And I have this. And this is kind of the general equation that I'm going to use. So down at the very bottom of the page here, it says slope point form of equation of a linear function. I'm going to switch the order again. Maybe this is where it's getting really confusing, but we're going to write it as y minus y1 is equal to m times x minus x1. So we're saying if we know the slope, m, and we know a point, p, it's called x1, y1, we can figure out the equation of a line. Looks a little bit different. So this type of line is perhaps one that doesn't have a perfect integer value for y. What I want to do for a second is just jump over to the formula sheet, because the formula sheet, the one we printed off at the beginning, we haven't looked at this for a long time. We used it a lot in Unit 2, unit conversions, and then shapes, areas, volumes. We haven't done anything with it. But if you look right here on the first page, there's this little box. And it has all of the equations of a line. Y is mx plus b, we've talked about already. This ax by plus c is the general form of a line, which we're going to talk about next day. And then you'll see the slope point form of a line. And then you have down here your slope of the line. We're going to do all of this stuff in unit number 8. And basically that's everything in the formula sheet. So all of the things that I just mentioned, the equations of a line, there's 3 different ones we're going to study. They're all here. Slope of a line, it even says, hey, this is how you find the slope of a line. If you forget m as the slope, it's all there. So just a little box. You don't have to memorize any of this stuff. It's all there. All right, let's continue on with the lesson here. So we have this sort of another way to write a line. If we know one point and the slope, so 2 things, we can actually figure out the equation of a line given those 2 things. So let's look at some examples of what this is going to look like. So example number 1, describe the graph of a linear function with the equation and then graph it. Okay. So we have an equation, y minus 2 equals 1/3 x plus 4. This doesn't look like what we've dealt with so far. Everything we've dealt with so far kind of look like mx plus b. So we had the slope and y-intercept form. But we don't have this b term in this example. The slope or m isn't super obvious. And then we have, other numbers that are kind of hanging around in here. So this is just another way to represent a line. Compare the given equation with the equation in slope point form. Okay, so slope point form, just the general slope point form is given right here. And I'm just going to rewrite the same equation just below it. So we have y minus 2, I'm just taking this and moving it down, equals 1/3, then I have x plus 4. Now just comparing these 2 things, if I just said, okay, I have y and y, that's good, I have this and this and this and this, could you figure out what this is going to look like on this graph? The idea here is we're trying to plot this on our graph. The first thing I see is m is whatever's in front of this x stuff, and in this case, it's just 1/3. So I know that the slope of my line is going to be 1/3, or my y-intercept. So that's maybe the easiest thing to recognize. The other thing is trying to find a point. In order to plot this line, we've got the slope, but if I have the slope, I don't know which point it goes through. So it's a bit tricky in that regard. So in order to plot a line, I need 2 points or the slope and 1 point. Now, if I just kind of scroll up here, it says the point that I'm trying to find here is x1, y1, which is this guy here and this guy here. So we have y minus y1. So that's the y value of my point. And this is the x value of my point. So let's see if I can kind of use that down here. So it looks like my y value is 2. And then the tricky thing is, and Abby, you kind of are a bit ahead of me, this negative sign is now a positive sign. So I'm going to have to deal with that because the general form is x minus x1, but I have x plus 4. So my point, or from here, I have my y1 is equal to 2, and then I have x1 is equal to, and this is where it gets tricky because it should be x minus x1, but it's x plus 4. So if I'm thinking really, really hard, and Abby did this already, if I had a negative 4, you don't need to write this down, but it looks like this, x minus negative 4, and my two negatives give me x plus 4. So that's all I'm doing is I'm subtracting negative 4 to get that x plus 4. So my x1 term is negative 4, my y1 term is 2. So my point, you can call it p if you want, it's going to be negative 4 and 2. I know my slope, I know a point, I can plot that. So my slope and my point. I'm going to plot my point first, negative 4, 2. So there is negative 4, 2. And then I can use my slope. Rise is 1, run is 3. So I'm going to go up 1, I'm going to go over 1, 2, 3, and then I can plot another point. I can do that again if I want. I go up 1, over 1, 2, 3, and I can plot that. Now we only need 2 points, but I have 3. I'm going to try to connect these points with a straight line. And there we have it. So I guess we could come up with like a general sort of rule. If you have y minus y1 and x minus x1, I guess 100% of the time, whatever the sign is, you can flip it if you want to think about it that way. If you're getting kind of confused, like, oh, the negative 4, where did that come from? Well, here I had a positive 4. So if I take that positive 4, my actual point is going to be negative 4. And over here I had a negative 2. So my point is going to be positive 2. So if you want to think of flipping the signs to get the point, that kind of works, and that'll always work. So this example 2 is a little bit more like what the questions you're going to see are going to be like. So writing an equation using point and slope, write an equation in slope point form for this line. Okay, so we have 2 points on our line. And we're going to use those points to find the slope, and we have the points so we can use those points in our equation. So it asks for point and slope, so we're going to write down the general equation. This is kind of a bit, not necessarily tricky, but if you are heavily relying on this formula sheet and it says slope point form, you need to remember of the 3, which one of these 3 things is slope and point form. So this is slope intercept form, this is slope point form, and then we have the general equation of a line. I'll talk about that a little bit next day after we do the general equation. So let's just go back to the example. We want slope and point, which is y minus y1 equals m x minus x1, where our point P is x1 and y1. All right. Let's first find the slope because we need to know what the slope is. So let's figure out what m for this line is. Now I have 2 points and I can use those to determine the slope. They're already drawn in. It's kind of nice. So I'm going to rise up I'm going to go up 1, 2, 3. So my rise is 3. I'm going to go over 1, 2, 3, 4. My run is 4. So the slope is 3 over 4. Okie dokie. I have some points here. I should probably figure out the coordinates of these points. Let's start at the left here. I have this point. It looks like it's -1, -2. Maybe write it off the graph. -1, -2. And I have this guy up here, which is 3, 1. All right, so I can pick either one of those points. Doesn't really matter which one. Maybe someone throws one into chat and we'll use that one. So when we have it in slope point form, we have our slope, we have a point, we have sort of 2 x's and 2 y's. We need to fill one of the x's and y's in with the point. So in this case, whatever point we choose, we're going to put it in. We have m is the other thing we need to fill in. So we're going to have an x, a y, and then a bunch of numbers. That's kind of where we're going here. So I don't know, let's pick the point on the left here, -1, -2. And we're going to plug that in to our equation. So we're going to say our point is -1, -2. We could have picked 3, 1 if we wanted. That would have been fine. But we want to pick one of the 2 points there on the line. Any other point that's on the line would work. It's just that those 2 points are kind of given for us or to us, so we want to stick with those. So what I'm going to do is plug the point into the equation. So I have y, and I'm saying y1 is -2. So I have minus -2. Equals, my slope was 3 over 4, so I'm going to put 3 over 4 in for where m was. And then I'm going to have x minus, and in this case, my x value from over here on the left was -1. Okie dokie. So we have a lot of double negatives happening here, so I'm just going to simplify them and get rid of the double negatives. I have y minus -2, so I'm going to have y plus 2 is 3 over 4, and then I have x minus -1, which is going to be x plus 1. And now this equation is in slope point form. I know the slope, I know one point, and that is the equation in slope point form. Had I used the other point up here, 3, 1, it would have looked a little bit different, but it would have been the same thing. I would have ended up plotting this point up here, and then using that information to use my slope to figure out what the line looked like. So it just depends on which point you're picking. So that is taking some information from a graph and putting into slope point form. And again, the reason that the slope-intercept form doesn't work is because we don't know what the y-intercept is. If you look really closely here, it's not going through a perfect integer grid point on the vertical axis. So I can't say that's -1. It's not. It's between -1 and -2. So I can't use slope-intercept form. I have to use slope point form. The second part of the question asks us to calculate what the y-intercept actually is. So what I'm going to do is, and again, I forgot to delete this, we're going to take our equation, y plus 2 is equal to 3 over 4 x plus 1, and I guess the easiest way would be to change to y equals mx plus b form. Because if I can convert it to that form, I can solve for b. That's the point of the question, is to figure out what the y-intercept is. So again, we're just going to do a little bit of algebra. We want to get y by itself. We want to end up with this y is mx plus b form. There's many different ways you can do this. I'm going to start with y plus 2. And what I'm going to do is, I'm going to take this 3 over 4, and I'm going to distribute it through the brackets. So I'm going to get 3 over 4 times x plus 3 over 4. Now, I want to get y by itself, so I'm going to move the 2 that's hanging out with the y over here. I'm going to move it to the other side, subtract 2 from both sides. And that's going to leave me with y is equal to 3 over 4x plus 3 over 4 minus 2. All right. This 3 over 4 minus 2, these are just two numbers. I have a fraction and then a 2. So I'm going to add and subtract fractions. I need to have the common denominator. So I'm going to just take my y is 3 over 4x plus 3 over 4, and then I'm going to convert this to negative 8 over 4. Because this is like 2 over 1. I need a 4, so I'm going to multiply by 4. I'm going to multiply by 4. That's how I get the 8 over 4. And then just one last step here. Y is equal to 3 over 4 times x. And then 3 over 4 minus 8 over 4 is negative 5 over 4. Now, this thing is in y is mx plus b form. So it turns out that the y-intercept, what the question was asking me for, b is equal to negative 5 over 4. That was the whole purpose of the question. Does that make sense? 5 divided by 4, 4 goes into 5 once, and then we have a quarter, so 1.25. If I look at the graph here, it's between negative 1 and negative 2, and it's really close to the negative 2, so I'm thinking that's probably pretty accurate if I were to check that. So that is basically it. Questions from this unit will involve, this section will involve you looking at a graph, figuring out the equation, looking at an equation, plotting it on the graph, and then converting to slope-intercept form, or converting from slope-intercept form back into slope-point form. Those are really the ideas, or the things we can do. Now, let's look at the learning guide. This is page 5. I believe, page 6. Finding the equations of linear functions. So you can see that these are in slope-point form, and it asks you to find the slope and the point. Should be fairly straightforward. Write the equation in slope-point form again. So we're talking about y minus y1 is equal to mx minus x1. That is what slope-point form is. Graph the line in slope-point form. And then general form, we haven't done yet. So this is going to be, what are we on? Lesson 5 today? Is up to there, which is midway through page 7. This is page 7. So that's all we'll do. And then we have general form next day, which will be the last stuff. And then intercepts you've already done, which is kind of nice. So it looks like there's lots of things left, but it's really not that bad because all the intercept stuff you've already done. So don't be like, oh my gosh, we only have one day left. We're going to have we need to talk about x, y-intercepts again, which we did in the last unit. So it just comes back again. It's another way to plot a line. So that's kind of where we're at. Does anybody have any questions about anything we did today, or anything from the learning guide that looks like it's going to be confusing, or things that you've gone through that are going to be confusing? I'd be happy to go through those. If nobody has any questions, it would be a great time to just maybe get through a few of these problems. There's a couple of quizzes there for you guys to do. A few of you are still working on Unit 5 stuff, which I'd really like to get done before the break. And I don't have anything else today. It's pretty straightforward. The last section, general form, is pretty much the same as what we've been doing. Just another way to look at a line and just kind of converting back and forth. So if nobody has any questions, and it doesn't look like anyone does, we'll have lots of time tomorrow to go through any questions you guys have. And then it's our last section. Wednesday will be a review. And then you can get the test written at the end of the week or on the weekend. That's it for me then. Tomorrow I think we're going to the food bank at, I have it written on my schedule here, and that hasn't changed. Where to go? Food bank, 12:30 to 2:30, and that is on Ellis Street, 1265 Ellis. So it'd be great to see you guys out for that. I know a lot of you had a really good time at archery, which was really fun on Friday. And if you haven't gone, you can come next week on Friday again, this week I should say. And if you did go, it's going to be a lot faster this time because you guys have already done your training and everything. So it'll just be the whole time you just get to shoot, which will be really fun. So if you didn't go to archery, everybody had a good time. It was really good. And you'll be able to shoot a lot more this time because it'll be a lot faster. So that's it for me, and I will see you guys tomorrow, first thing, right after Mrs. Wood's done in the morning. Thanks.